Hello, this is Mrs. Razor, and we're going to be looking at Lesson 1 in Chapter 1 today. You should have your note sheet out in front of you that looks like this. It's 3 pages, and we're going to go through some of really the foundational things in geometry, a lot of terms, a lot of definitions. The great thing about taking notes this way is that if you get stuck or you need to see something again or go back and rewind or pause, you have the ability to do that on this video. I do expect you to take notes on your note sheet as we go along and work the examples out with me. Our objectives today are to identify, name, and draw points, lines, segments, rays, and planes. We will also learn how to apply basic facts about points, lines, and planes. A lot of vocabulary in today's lesson, and we will be going over all of these. Most basic figures in geometry are called undefined terms, which cannot be defined by using other figures. The undefined terms point, line, and plane are the building blocks of geometry. The reason why they're undefined is that things such as a point actually don't have a size per se. It just names a location but doesn't have a size. A line technically doesn't have a thickness. So even though we draw a representation of a line, there actually is no thickness, and the same goes for a plane. So let's look at our first 3 terms in the geometry world. Again, these are the building blocks, these are the foundations for geometry. A point names a location and has no size, is represented by a dot. So the way that we would draw this diagram is just to put a dot. That's how we would represent a point. And then we're going to name it with a capital letter. And I will name it A. So you can write point A for the name, or you could also simply just write the letter A. That's okay as well. Any uppercase letter will work, but again, it is an uppercase capital letter. A line is a straight path that has no thickness and extends forever. The way we will represent this in our diagram is by drawing the straightest path that you can, and maybe you can grab a ruler to do so. And because it goes on forever, we're going to put an arrow on both sides. A line has an infinite number of points. I'm going to go ahead and put 2 points in this line, because this line is going to help me, these points are going to help me name this line. So I have placed points B and C on this line. In order to name this, I will write those capital letters, B, C, and then I will draw a little line with 2 arrows on the top of those capital letters. So that notates line BC. Just a note, you could also write it as line CB, if you so choose. The order doesn't matter, but they do need to be capital letters again for those points. A plane is a flat surface that has no thickness and extends forever. The way we will draw a plane actually looks a lot like a parallelogram, and this parallelogram may not look so great. I'm not the best at freehanding on this software, but it'll normally look like a parallelogram. We're going to place 3 points on this plane, and let's call these points D, E, and F. The way to name a plane is actually to take 3 non-collinear points, and that's going to be an important word. You'll notice that there is a box there on your note sheet for the word for the word collinear. There's also something called non-collinear, and we'll get to that here in just a minute. When you name a plane, you can either write the name plane out front, plane, and then call it DEF. Notice when we name a plane, we use the 3 points. We don't put commas, we don't put spaces. Just like if I was to write my name, Razor, I would write R-A-Z-O-R with no spaces and no commas. The same is true here. You could also name a plane without writing the word plane, and you could do it in a different order. You could call it plane EFD if you wanted to. So like I said, there are 2 important terms that are listed below your first grid there, collinear and non-collinear. Collinear means to be on the same line. Notice the word line is inside collinear. And coplanar means to be on the same plane or on the same flat surface. You can notice here you have the beginning of the word plane in coplanar, but not quite the whole word. You can also have things that are non-collinear and non-coplanar. So some examples here. Two collinear points would be points K and L. Notice I put a comma between those to separate that it's 2 points. It's not the name of something else. It also says here that K, L, and M, all three, are collinear. However, K, L, and N are non-collinear. So notice K and L are on the same line, but N is not. So they are non-collinear if all three of those points don't land on the same line. Coplanar, technically there's just one plane here. It's our flat surface that basically is our sheet of paper. So all four of these points would be coplanar. And if they were not all on the same plane, then they would be non-coplanar. Let's look at the other 4 points that we're going to discuss today. The first one is segment. A segment or line segment is the part of a line consisting of 2 points and all the points between them. It is part of a line. However, there is a beginning and there is an end, which means if it doesn't go on forever, there will be no arrows on this diagram. So I'm going to put a beginning of C and an end of D, 2 points, and when I connect those 2 points with a straight path, then it creates a line segment. Not a line, but a line segment. The way we for sure know it's not a line is that there are no arrows. So when we name this, we'll use C and D, but when we put the symbol above it, it will look like the segment and not the line with no arrows. An endpoint is a point at one end of a segment or the starting point of a ray. In order to demonstrate this, I'm just going to draw arrows to C and D because C and D are endpoints of segment CD. I would also like to note that we could have named the segment as DC. Again, the order doesn't matter when naming a line or a segment. Also remember that when we name points, we use capital letters. One of the endpoints here is C, and the other one is D. I did choose to use a comma here because I'm separating 2 figures, not just naming one thing. A ray is a part of a line that starts at an end point and extends forever in just one direction. So I'm going to give myself an end point of E. I'll give myself another point, F. I'm going to start my line, my ray, at E and go through F. However, it does go forever in one direction. So I will be putting an arrow on that part of the ray that went past point F. You can name this ray EF. This is the best way to name this ray, although we could technically name it FE. Notice that my ray doesn't start at F, so this way is not the best way to write this name because this makes it appear as if the ray starts at F and goes through E, when in actuality it starts at E and goes through F. So this is the best name. Notice again that there is only one arrow because it only goes on forever in one direction. When we look at opposite rays are 2 rays that have a common endpoint and form a line. I'm going to give myself a common endpoint of G. I'm going to draw my first ray starting at G and going through F. So we'll start at the endpoint G and go through F. It is a ray. It goes on forever in one direction, so I need one arrow. However, opposite rays, that means I need to draw another ray with the same endpoint, so I need to start at G again, but I need to go in the exact opposite direction. So I'm going to start at G and go opposite, which in my case would be left. It goes on forever in that direction, and we'll put another point on here, H. So when I look at this diagram, although it looks like a line, and it does form a line, it was actually created with 2 rays. The first ray was ray GF. It started at G and went through F. The second ray started at G again, but went in the opposite direction through H. Notice that I didn't point the second arrow going left, even though it goes left in my diagram. You can have rays going up, down, left, right, slanted up and to the right. What matters, though, when you name it, is that you start with the endpoint and then write the point that it goes through. Then you can always draw the arrow going to the right. That will be the way that you will see rays named and noted. Let's look at the back of your first page. There you will see some postulates. A postulate or an axiom is a statement that is accepted as true without proof. Postulates about points, lines, and planes help describe geometric properties. So our first postulate says through any 2 points there is exactly one line. If you think about it, even for just a minute, if I draw points A and B, and I draw the line going through them, is there really any other way to draw that picture? Some of you might think, well, sure, I could start at A and still go through B like this. But that's not right, because if you do that, that's not a straight path, which means it's not a line. So there's only one straight line that will go through any 2 points. Notice here I cheated a little bit, and I gave myself 2 parallelograms for planes. On this postulate, 1, 1, 2, through any 3 non-collinear points, so I'm going to put 3 points that are not on the same line, there's exactly one plane containing them. Postulate 1, 1, 3 says if 2 points lie on a plane, then the line containing those 2 points, if I connect those 2 points, the line containing those 2 points will also be on the plane. That basically means the points are on the flat surface of the plane, which means the line will also be on the flat surface of the plane. Our other 2 theorems are if 2 lines intersect, then they intersect at exactly 1 point. To demonstrate that, all you need to do is sketch 2 lines and notice that where they intersect does in fact form a point. I already gave you the picture for the next postulate because that's a tough picture to draw. If 2 planes intersect, then they intersect in exactly 1 line. So you'll see there that you have a lighter plane and a darker plane that intersect. Let me pull up your note page here. On mine, it's a purple plane and a green plane. The dashed area, the dashed line that you see is actually behind. That's why part of the diagram is dashed and part of it is solid. And where these 2 planes intersect, there is exactly 1 line that is formed between them. We will go over these terms and these postulates again in class. The examples on the rest of your note sheet we will also go over in class, but I wanted you to be aware of all the terms that we were coming up with that we will be building the rest of our geometric foundation upon.